Okay, so it looks like we're going. We're back, and today I want to keep looking at the downloader, the huge file that plagued me because I don't know anything about it. Vim save. We were line 466 on ETH downloader. So if we go into Go, source, GitHub, Ethereum, Go, and I open tmux here. I've got a different tmux to what I used to. And then I go into ETH/downloader. Downloader, if I open the actual file instead of making a new one, I'm at 466, and we've got these fetcher files. So they've defined here 4 functions: fetch headers, fetch body, fetch receipt, and process headers. And that is added to an array. So there's an array of functions. And then that gets passed to this spawn sync function, which iterates over them and calls them. Now, what I imagine is it spits open a request for every single block via these, and then it processes them, and depending on whether it's a fast sync or a slow sync, it'll be more or less of these functions that have been defined. So spawn sync is here, goes through full length in fetches, function equals fn, and they pass function to error C. So this is where it actually gets called. And if I go down a bit, what does it do? It does nothing. It really just calls those ones. Spawn a sync. So let's just look at fetch headers. First one. Retrieves headers concurrently from the number requested. So if I go back here, we'll look at it because it will say the from and pivot. And the from is where you've gone back and you've found the block that you and a peer have in common. So ideally it'd be your last block, and then you're just grabbing everything anew till you catch up to that peer. But it might be you have to go back 100 blocks to get something that you've got in common. But I imagine if everything's done right and there's no malicious nodes, you should only have to go from the most recent. So it's calling fetch headers with the from, which is your latest one, and pivot. And pivot was defined as like 64 blocks before the end. And I think that, I'm not fully sure if that's right, but once you get to 64 blocks before the end, even if it is in fast mode or light mode, it will check everything. That's my understanding so far. We're going to verify that, but so fetch headers origin +1 to pivot. And pivot was defined here as you went 60. Pivot equals height. So pivot might be 0 if you're full sync. If it's fast sync, it's minimum full blocks, which is defined upwards, I guess. Yeah, 64 full blocks. Number to retrieve even if you're in fast sync. So fetch headers. Headers are always retrieved. Bodies retrieved doing normal and fast sync. Yeah, okay, cool. So back to fetch headers. Don't need that. Let's go over here. How big is this? Don't be big. Lots of if statements. Okay, so no, it's decent size. Fill header skeleton. What does that mean, you reckon? Say log directing header downloads. We've got the skeleton equals true. Skeleton assembly phase. So they got a phase that does something. Who knows? Skeleton. So I assume it builds the headers and doesn't get the bodies. Maybe, I don't know. Who knows? So set some timers. Set a timeout. And defer timeout.stop. So they're putting some limits on how long you'll wait for a peer. Get headers equals a function. And then they call get headers with from. So request time to live, request if skeleton, fetching skeleton headers, fetching full headers. And the difference, like, okay, so you got your peer and you made the request here. So this actually sends out the HTTP request. So the peer saves all the IP address and stuff for your peer, and then you call this request headers by number to get a header by number. So we've passed the from. It's really just calling that. We went through the peer file a little bit earlier this month for from. And max headers fetch. So it's got a skeleton size here. I don't think I want to look at that right now because I don't know what a skeleton does, but we want to look at what a full thing. So request headers by number. It actually calls it, so they define a function and then call it. And then they got this select, so you know it's waiting for something to happen. If you get a cancel channel, it cancels. If you get a packet as a header channel, if the peer ID does not equal the peer ID, means someone else sent you a packet. It's kind of funny. If the skeleton is finished, pull in any remaining headers directly from the origin. So if there's no items in the packet and you're doing skeleton, they say call get headers from. Which is what it did. So it sets skeleton to false and does the same thing. So I guess the skeleton might just be building when you're getting all the headers for each block, you're only getting like the hash of the previous one and the number maybe. And that way you can do the work and concurrently request all of them, but you don't have to download all the header information, which is interesting. Okay, cool. No more headers are inbound. Waiting for pivot commit. So this goes through if there's no more items in the packet. And when it does this, it returns. So if there's no more items in that, you receive a packet back from your peer. If there's no items in it, which is something defined in it, I guess, you escape. If not, you now get to here and it says the headers equals the header of the, which I guess gives you an array. Fill header skeleton from headers. That was the next function after this one. Field proceeded. We'll have to look at that. Else, we're closing in on chain head, but we haven't reached it yet. Delay the last few headers, so many orgs. Head, filled. I have no idea what filled means. Where is filled defined? Up the top. I guess they've made like an empty array called filled. Nah. They've just defined it. Fill header skeleton from. No idea. From flar. So what is D then? Where's this D coming from? The downloader. Yeah, that makes sense. It's in the same file we're looking at. So if we're looking at here, it says fill header skeleton from and headers. So we've extracted the headers out of the packet, passed that to this next one. If it's given an error, blah. Else, we're closing in on the chain head, but haven't reached it yet. Delay the last headers so the mini reorgs on the head don't cause invalid hash on chain errors, something. Current fast block. If head equals current block number, head equals full. Headers equals that plus n minus delay. Nah, so where's headers there? If the length of headers is greater than 0, retrieve the current head we're at. Insert all the new headers and fetch the next batch. So then they pass all these headers to this header procedure channel, I guess. And that will now deal with all these headers and put it into the blockchain that we're maintaining. So all this is being done very asynchronously. They're called get headers from. From plus equals. So you get the headers in the packet, you extract those headers into this headers file, pass that to this procedure channel, increment your from, and then call get headers on the next X amount you're going to do. That all makes sense. Timeout, if you get a timeout, you drop the peer. And that's it. So that all makes sense. There's 200 lines there just to say if we receive a packet, safely extract the headers into another channel. And we will see what that get headers from does. It's the same one, so they're calling it again. It's within the function, they've defined it. Cool. Straightforward. So we'll go header proc channel. And that looks like something that receives it. Process headers. Okay, so this is the last function they call. And in there, after all the headers have been added, they will deal with them. That makes sense. The first one literally just fetches them and puts it in this big long list. Cool, cool, cool. So you fetch the headers. In this point, they're talking about building a skeleton, fill header skeleton, which is going to be this next function here. Retrieves the headers from all our available peers and then maps them to the provided skeleton header chain. Let's do a quick Google of that. Skeleton header chain. Ethereum block architecture. Nah. Sharding. Can't synchronize. Yeah, it doesn't say. No clue. I'm assuming it's just saying that there is that they request, instead of requesting all of the header, just the hash. Okay, cool. Q has a skeleton. Download has fetch parts. Pending headers. Retrieves headers from all our available peers and maps them to the provided header chain. Cool. From skeleton. Types of header. Array of headers is the skeleton, and they pass it to this schedule skeleton. So schedule schedule skeleton adds a batch of header retrieval tasks to the queue. So I really don't understand what the skeleton. Make all these tasks for the queue. Index equals from plus that. So I think it just schedules more requests. That doesn't really help me. What else were we looking at? Let's go look at the peer. So up here they did a request headers. Keep going up. Request headers by number. p.peer. So a light peer interface just has a request headers by number, which I imagine if we go up to the top level and find peer-to-peer, and somewhere in here there's a peer. Nah, it's gonna be an ETH, isn't it? So what's a peer connection.peer got? There's no peer in there, so I don't know what that's going to show up as. Cool. So the downloader is requesting headers from the peers, but I can't find where it's doing it right now. Downloader, peer, where it already was. So something's implementing this light peer interface, and then that, because that's the peer connection. So this downloader, that P is a peer connection, and in it is this peer object, which is peer, which is an interface to an interface. So if I do that again, somewhere in here, ETH handler. So in ETH, there's a handler. $294. Nah, that's calling it. There is an ETH. There is a P there. Why am I having so much trouble finding that? Okay, so here's a function that actually does it. Bloody hell, that was hard. Exit. So they got a peer, they've got an origin, they got an amount, they got a skip, they got a reverse. So send a message, get block headers data. Get block headers message. So peer-to-peer send, what's that send? So in here's peer-to-peer send. It's not in there. So back into peer-to-peer ACK send. Heaps of them. Message. Am I in the right place? No. Peer-to-peer message has the send. So you give it a message writer, a message code, a data interface. It's very good. So the writer, yeah, that's all good. Get block headers message. It's not there. cd and ETH again. It's in protocol. So in ETH protocol, they define the get headers message as 3. So when they're sending that message over the peer-to-peer network, it has a message status, which is going to be 3 for the get headers. And the data, which is an interface. There's get block headers data. Is that in here? And it's not there. Get block headers data. So somewhere in here, there's going to be a function. No, it's a structure in protocol. So they make this structure, which has got the origin block from which to retrieve headers, maximum number of headers to retrieve. So how much do they retrieve? Amount. Amount is sent. Here. Max headers fetch. $192. So you fetch 192 headers in a go. Get block headers data. So somewhere in here there should be a get block headers, max headers. Requires a peer to return a block headers message. Reply must contain a number of block headers giving rise when the reverse. Rising number when reverse is 0, fall in when 0. So if you're at block 100, you send 100 plus the max headers 192. So you request from 100 to 192. Rising number. So in here, you're calling, go back to there. So this function, fetch headers, is called with the origin and pivot. That goes to fetch headers. And then that calls the peer with the request headers by number from. And that ideally will be your most recent block because you want to get everything newer than what you've got. This max headers fetch is defined as 192. 0 is, I think, going to be that rising. Reverse equals 0, fall in when 1, and false. So that goes to here, request headers. est headers by number. Reverse equals reverse amount. Yeah, it is skip. What is this skip integer? No, that's a boolean, so that's the false. So when they're passing false, that means the reverse is not set. They're saying skip here. Max header fetch -1. And then they just make that structure. That structure gets put into RLP. That gets sent over the wire. And then that goes back to here. And it goes back into this channel. This channel goes into which is going to be the process headers channel, header process channel. And then that's it. That's all that function does. Fetch headers. So spawn sync, what does it do? Goes through each of them. So they pretty much get spat out straight away. It's like send out one, send out one, send out one, send out one for the 4 functions that it wants to do. Maybe 5 if we include this one because there's a fast sync, full sync content. Oh, no, so there's a function here now. So there's 4 functions here: headers, bodies, receipts, process headers. And then if you're on fast sync, it puts another one. If you're on full mode sync, it does this other one. Cool. Very good. So let's go find what fetch bodies does. So fetch bodies iteratively downloads the scheduled block bodies, taking away any available peers, reserving a chunk of blocks for each, waiting for delivery, and periodically checking for timeouts. Downloading block bodies. Defining some variables. What are they? Deliver equals a function that takes a packet. Yeah, so they're wrapping some variables, some functions into variables, which will just do the requests easier. So there'll be a deliver with a packet. Fetch bodies. So they're calling this fetch parts function and passing it absolute goddamn huge number of parameters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 parameters to fetch parts. Iteratively downloads scheduled block parts, taking any available peers, reserving a chunk of fetch requests. So this is a big description. Probably because there's 15 parameters going into it. And then fetch is the most important. Where do they call that actual fetch number? Somewhere here. Now it's got to be before this. So this is the brutal function header. In-flight fetch hook. Fetch is a function that does here. Idle, idle, idle. Returns an error. Create a ticker. Prepare the queue and fetch blocks until it's done. Packet equals delivery channel. If the peer was previously banned and failed to deliver its packet in reasonable, ignore its message. So where does it actually call it? I don't know. Fetch parts, iteratively download scheduled block parts. If there's something in a delivery channel, if there's something in a wake channel, if there's a ticker, update. Peer fetch. Pending equals 0. So here's the actual call. For in peers. Nah, that's okay. So they're going through this check to make sure there's nothing telling the program to stop. So like if there's something that's been delivered already, or if there's a wake channel, I don't know what that is. Or something comes through to this update channel, then they deal with those first. Otherwise, for peer in range idles, so they go through the idle peers. And reserve the peer capacity peer. Fetched peer and request. What was request? I don't know at this point. Going back and forth. I imagine it's going to be passed in this big list of parameters. Request equals reserve capacity peer. So this is where they actually call, because they call in this fetch, the peer and request. It means that we've double allocated a fetch task to a peer. So they call the fetch on it. So it digs up a idle peer, then calls fetch on it. And if we go up, this is receipts. We don't look at receipts. This one, they call fetch parts. They define this fetch as just fetch bodies request. If I go over here, I'm assuming there's a fetch bodies here. Maybe not. Nah, it definitely says fetch bodies. Download appear. So in download appear, there is a fetch bodies. And this is what gets called with the request. Convert the header to set retrievable slice. Call.request bodies, which is this one. It says an array of hashes set up here. Is that what that's building? For range headers, header.hash. So you've got the headers so far, and you want to get the bodies. So the first thing they do is get the headers. Then they request the bodies, which is an array of hashes. Get block bodies message with an array of hashes. So this is what they're calling here. So you got the hash 0, hash 1, 0, 5. Makes lots of sense. Okay, cool. Once they get all those, what do they do with them? Deliver bodies. Body channel deliver. They're called deliver bodies, I guess. On the queue. So there's a transaction list, an array of transaction lists, an array of transactions. A block is an array of transactions, therefore a list of blocks is an array of transactions. So lock it, reconstruct. They define this function, queue.deliver. Injects a data retrieval response into the results queue. Cool, so they get all the bodies back and they put it in this deliver list. And then they spin up more processes to deal with that later. The last thing they do in here is fetch receipts before they process the headers. And they do the same sort of thing here, and they call fetch parts. So they call the exact same thing. So what does fetch parts do after it receives them? So it does its check-in, and it goes into... Where did it go? These call fetch. That's all they're doing. And then they close it afterwards. Reserve peer. So where's the deliver function go? Where's that tie into it? So deliver is a function, it's got a deliver packet. Nah, okay, so that's if something else has received before it, delivered. So if they receive something, they call deliver packet. Set idle. Packet.stats. So they call deliver packet. Does that loop though? It does loop. So it sends a request and loops. And then once it gets delivered, it calls deliver packet. And up in receipts, it defines deliver packet as deliver receipts, which is in this queue. They get a receipt list, reconstruct headers. They just wrap it and then pass it to this, into the results queue. What's the results queue? There are so many parameters into this. Results integer. Length receipts list. So it goes through all the headings. If I is greater than the results, so it's error. index equals the number, then a call reconstruct on it. Done pull hash equals structure. So they really call that reconstruct function on it, which is defined up here. Derive SHA, results dot receipts equals receipts list index. So header has an index, has a result. Types dot receipts, receipts list. So there's this receipts list. Where's that go? Pack.receipts. So they define pack here, and that's their array of receipts. So a packet receipt pack. So they call fetch, which fetch the receipts. What all it does is wrap it. Then when that's done, it calls deliver, and it puts the delivery receipts into this pack. And then what? What happens once it's in that pack? Results.receipts equals receipts list index. I'm not sure. I'm going to have a look at the next one though. .n. Process headers. Takes batches of retrieved headers from the input channel and keeps processing them. So we've got this now. So you're always going to process the headers whether you're fast sync or not. There's this deferred function for when it closes. For headers equals header process channel. Otherwise, split the chunk of headers into batches and process them. For the length of headers greater than 0, limit equals length of headers, chunk equals headers up to the limit. Light chain, insert chain. Oh, so now they're calling this insert header chain into the light chain, if it's a light chain. If it's full sync, or demode equals fast sync, pending blocks, max headers. Update the highest blocks to know if we found a higher one. Chain height is greater than origin. origin plus equals limit. Chunk equals headers. You've got to validate the chunk immediately. It's 26 lines there. If not, lightchain has header.hash. So they iterate through every header in the chunk. So there's unknown headers and mark them as uncertain. If it has header, if we're importing pure headers, validate them on their recentness. If it's greater than pivot, frequency equals 1. Insert header chain. Cool, so you go through each of the headers, build this unknown headers, which we're going to put into our chain. No, unknown are ones that aren't in. Header to hash has header. So whatever this has header is doing more than I think it is. So it's looking at your chain and checking that this header makes sense to exist by saying at this hash, this one, and then it probably traces it back. If it's not in there, it has an unknown header, which will have to be looked at later on. And then if insert header chain, so somewhere there is a function called hasHeader and insert header chain. And I imagine it's in blockchain. CD core into insert header chain. Yeah, so it's in header chain.go. So if I go up into core header chain, there is the insert header. There's the insert header chain, and there's also has header. Yeah, cool. So it checks if it's present in this database or not. And it actually searches for it. So it inserts all the headers into the database, and then it calls this has header, make sure it's in there, which should be the same, and then it calls insert header chain chunk. Attempts to insert the given header chain into the local chain, possibly creating a reorg. If an error is returned, it will make some stats, for I in header in range chain. If there's a interruption, escape. Then it calls write header into the header. It calls write header with the header. So calls, no, because it's not actually a write header callback. Insert header chain. Insert a header chain, chunk and frequency.